businessman who is planning his business tour from Mumbai to Kolkata, in the course of which he is proposing to cover at least one city from each of the company's different marketing zones and route. As he has a limited time at his disposal, he has to complete his tour in the shortest possible time. The network shows the number of days involved in covering any number of intermediate cities, and the time include travel time plus work time. Determine the optimum tour plan for that particular salesman. So this is the numerical, right? So after after you have drawn the network diagram, you should be able to identify the zones as well, right? So they haven't given us any zone also. So we should be able to identify the zone so that we can break our problem into different stages, right? So now I think that from the last numerical, you would have understood, or at least you have got a sense that every zone is acting as a every it is acting at a different stage, right? So here our B and C, so you can write, no, so this particularly happens to your zone 1, right? Then nodes D, E, F, G happens to your zone 2, right? So F, I, J, K happens to your zone 3. This is your zone 4, and then you can say this is zone 5, or it is start and end, right? So zone 1, zone 2, zone 3, and zone 4 are been no, those have been identified, and that will be helping us to break this problem into different stages, right? So it is a multi-stage decision problem. So when we reach at zone 1, so starting from the start itself, we have to decide in uh, which city we have to go for, B or C. So when we have reached at B, then we can have different option. Even if we reach C, we have different options. So we have to take some decision at B or C itself. So in every zone we'll have to take some decisions, and that hence is called as the multi-stage decision problem, right? So let's start solving this problem. It is easy problem only, but there is some understanding that is required. Thank you. Right. So let's start with this. Right. So what we have started with this numerical, right? So stage 1 we have completed. These were the preceding node was only our single node, that is A, and the stage 1 nodes were B and C. Here you can see it is 10 plus 0 and 11 plus 0. So 10 plus 0, 11 plus 0, and F1 star we have 10 and 11 respectively, right? Similarly for the stage 2, if we see the stage 2, the nodes are D, E, F, G, right? And the preceding nodes were B and C. Likewise, we have finished the table. So if you see from B to D, right? So from B to D, there is a route that is there. From B to E, there is a route. From B to F and from B to G, there is no route. So here you can see F and G, we have kept it as backend, right? Similarly, for C, from C to E there is a route, from C to F there is a route, and from C to G there is a route. But there is no route from C to D. So we have kept C to D as vacant, and likewise we have completed. So we have completed stage 2 as well. They have got this optimum value for D, E, F, and G nodes. Moving ahead, stage 3. So we have written the recursive function here. The recursive function is F3 is equal to R3 plus F2 star, right? So what are the stage 3 nodes here? Stage 3 nodes are H, I, J, and K. So likewise, we have written H, I, J, and K nodes here. Similarly, the nodes in the preceding stage are D, E, F, G, right? So now the R3 values, right? So R3 values that we have to identify. So from D to from D to H, the R5 value is 5. Sorry, R4 value is 5. Then D to I, the R4 value is 6, right? So again, from E to from D to J there is no route, and from D to K there is no route. So here you can see D to J and D to K will be kept vacant, right? Similarly, from E to H there is a route and the value is 6. From E to I there is a route, the value is 5. From E to J, there is a root and the value is 6, but there is no root from E to K. So the value here will be kept vacant. Here you can see E to K is kept vacant. Similarly, for f to I, there is a root, the value is 7. From f to j, there is a root, the value is 5. And from f to k, there is a root and the value is 7. But there is no root from f to h. So here you can see the f to h has been kept as vacant. Similarly, moving ahead, we have G2 J root and G2 K root, for which the values are 6 and 6 respectively, but there is no root from G to H and G to I. So G to H and G to I are kept as vacant, right? So all these R3 values we have got, right? And no, the F2 star values were there with us. F2 star value for your D node is 18. So for all the D node values, we have applied 18 as the F2 star, right? Nextly, for E node, right? So for E node, the 18 is the value. So for here also you can see we have put 18, 18, 18 here. For F node, the F2 star value is 19. So we have put 19, 19, 19 here, right? And for uh, G, it is 20. So here you can see it is 6 plus 20 and 6 plus 20, that is 26. So for H node, we have value 28 and 23 and 24. So the lowest is 23 that we have selected. Again, for I node, we have 24, 23 and 26. So the lowest value is 23 that we have selected. Nextly, it is 24, 24 and 26. So 24 is the least that we have selected. And next is the 26 and 26. So we can go with 26. Now our next stage, the next node values are L, M, and N, and the preceding nodes are H, I, J, and K. You have the root H to L, but there is no root from H to M and H to N. So H to L, the value here is taken as 5, and other are kept as vacant, right? Similarly, there is a root from I to L, I to M, but there is no root from I to N. So from I to L, the values are 6 and 6 6 and 6 respectively. So here you can see I to N is kept as vacant, while others have been allotted the value of 6 and 6. Nextly, from K to M, there is a root, and K to N, there is a root which has value 5, 5, but there is no root from K to L. Twenty-four. So we have taken 24, 24, and 24 here. And for K, it happens to be 26. So we have taken 26 and 26. Likewise, the values of the nodes that we get for L is 28, 29, and 31. So 28 is on the lower side. For the M node, it is 29, 31, and 31. 29 is on the lower side. For N, it is 28 and 31. 28 also on the lower side. The next stage is stage 5, and the recursive function we have written. The recursive function is f5 is equal to r5 plus f4 star, right? So here if you see from L to M, the value is, L to 0, the value is 3. From M to 0, the value is 4, and N to 0, the value is 4. So likewise, we have put the values as 3, 4, and 4. For L, the F4 star value is 28. For N, it is 29. For M, it is 29, and for N, it is 28. So we have put that. So we got the value for node O as 31, 33, and 32. The lowest among that is 31. So we have taken 31, right? So the minimum time that will be required for traveling from A to O, right? From A to O is what it is, 31 units, right? Now, as we have got time, we have to decide the path, right? Now this is very, very, very important, right? There may get no, you may have a confusion in this particular table. Let's particularly attend this table properly, right? So I need everyone's attention here. Starting from with a backward approach, we have 5 written here, right? So the optimal value that we have in stage 5 is what? It is 31. So we have written 31 here, right? So now the optimum value in the preceding stage, right? The optimum value in the preceding stage is 28, right? So two values of 28 are there. So we have written 28. But now we have to decide which node is to be selected, whether we should go from L or whether we should go from N, because both of them are yielding the same lowest value, that is F4, or that is 28, right? So what I've done is that I have done some calculations below, right? Stage 5. What will happen if we go from L0? The lowest value is what? The lowest value for L is 28, right? So let's see this network. For here, for L node, it is 28, and to reach towards O, it has to travel 3 units. So that means that it is 28 plus 3, that is equal to 31. So that I have written here. It is 28 plus 3 is equal to 31. Now let's move towards the node N, right? N also has 28 as the least value of least value. So if I'm here at N, my value is 28, and I have to reach to O. But to reach to O, what I have to, I have to invest 4 units. So 24 plus, no, sorry, 28 plus 4 is equal to how much? 32. But what we know is that the least time that will be required is 31. So can we accept 32 as a value? No, we shouldn't be accepting 32 as a value. We should accept that route which is sticking to the value of 31. So here you can see, if we go through N to O, so it is 28 plus 4, 32, which is not acceptable. So what is the right value? It is 28 plus 3, that is 31, and hence I have selected this L node, and hence I have written here L node, and my route comes out to be L dash 0. I'm hoping that everyone has got this, right? Let's move ahead. The optimum, the stage 4, right? The optimum value is 28 that we have already got, right? So even if in this table you see it is 28. Let's move towards our next, the Now, let's take another route which is again given by node I. So what node I says that is from I we should go towards L, and from L then we should move towards O. So I has a value of 23. So now 23 plus 6 is 29. So we reach here. 29 plus 3 is 32. So now my ILO route gives me the value of 32. So here you can see there are two possibilities. HLO, that will be giving us 23 plus 5 plus 3, that is equal to 31. And the root ILO will be giving me 23 plus 6 plus 3, that is 32. Again, I cannot accept the value 32. I will have to stick to the value 31, and hence I have selected the node H, and hence I have written it H here. Now my root is HLO, right? Now let's move towards our node 3. The optimum value we already have and written here, it is 23. Now let's move towards the stage 2 node. The optimum value is 18, and again there is a tie, and here we have nodes D and E into consideration. So now what it is saying that, we should, if I take a node D into consideration, I should go DHLO. So at D the value is 18. So 18 plus 5 is 23. 23 plus 5 is 28. 28 plus 3 is 31. So DHLO gives me the value 31. Now let's go with the root from EHLO. So EHLO, again it is 18 plus 6, that is 23. Sorry, 18 plus 6, that is 24. 24 plus 5 is 29, and 29 plus 3 is 32. So from EHLO I get the total value as 32 units, right? The same I have written here. DHLO, if I go to this root, it gives me the value as 31, acceptable. And EHLO, it gives me the value 32, which is not acceptable. So which value is selected? Which node is to be selected? The node D is to be selected, and hence the node now becomes DHLO, right? Now stage 2 optimum value is 18, right? Stage 1 optimum value we have to find out. So the optimum value among these two values is what? It is 10, obvious. There is no tie that is there. So we can take which node into consideration? B node into consideration. So what is the root now? BDHLO. Now the root that we have got is BDHLO, right? So here we have written BDHLO. Now the starting node is A, and we can write here, complete the table, and the final root that we are getting is ABDHLO, which is the optimum root. And what is the optimum time that we get is the 31 units, right? So when there is a tie, so you have to simplify this in this particular manner, and then after that you have to fill up in this table, right?